So guys, as you can see, we have these LEDs constantly blinking after every 200 milliseconds. Now over here we have a button. See this button. As soon as I press this button, see the code goes out of the main loop. See, it remains on for 3 seconds. Now see, now it is our loop within a loop, while loop, within a while loop, forever loop, which is like blinking forever with 200 milliseconds. Now we want to break this loop and go back into the main loop. We press this button. This button initiates the break statement. See, and we are out of that loop now in the 3-second loop. Okay, now let me show you the code how it's working over here. Now take a look here. We just initialize the port B because it has the LED. Then we initialize the button pin. Then what we did is that we didn't touch the main forever loop, because if we added the break statement in this loop, it will go out of this loop to the one-time loop and then the code will be hanged. So we use another loop. So once we break out of this loop, we are still in the main loop. So this while, that is a forever loop, inside it we wrote this command in the open. This command makes the LED to turn on for 200 milliseconds, and these two commands make the LEDs turn off after 200 milliseconds. So it will be on for 200 milliseconds, off for 200 milliseconds, and before turning on we check if the button is pressed. If it's pressed, just break. Once this break command is initiated, our code breaks out of this forever loop and goes into the main code here, and that's why it turns on the LEDs 3 seconds. So see, we are like checking for if the button is pressed at 3 points, before the LEDs turn on, after the LEDs turn off, and after the in the time span between the LED turning on and off. So you can add these at as many places as many you want, that wherever you want the buttons to be tested. So this programming gives us this result, simple as that. See, once I press a button, it will break out of the loop. See, simple as that. Hello guys, welcome to learning microcontrollers. In this video, I'm gonna show you why we use the break command in C programming, or it will be useful in every microcontroller like AVR Studio, Arduino, IDE, or any other programming software which uses C or C++. There is a break statement and you can use it, and it's a very useful statement. So I'm going to show you in this video how we can use this statement in MikroC for PIC. So let's get started, and I will demonstrate to you the result of the programming on hardware, and for that I'm going to use the PIC16F877A and 4 LEDs. So let's get started. So guys, this over here is our PIC16F877A microcontroller having 40 pins. It's a TIP version. Before we move forward, let me first show you what is the hardware I'm going to use. I will just use a push button and 4 LEDs. 4 LEDs will be constantly blinking in a loop, forever loop, but as soon as I press the button will initiate the break statement, causing the loop to end. So that's what the break statement do. It makes sure that your loop ends. It will jump you out of a loop. So let's try it. So guys, let's first of all get our 4 LEDs for demonstration purpose, 1, 2, 3 and 4. As you can see, each LED has 4 pins, one longer, one shorter. The shorter is always the ground. So this is our ground pin for the top LED, shorter one, this. These 4 are the ground pins. Common them and send them to the common ground of the PIC. Now for the longer pin, do not connect them directly with any available digital input output pin of your PIC. Use a resistor. You have 4 LEDs, so 1 resistor for each LED. Total we are going to need 4 resistors. Now this resistor is also called safety resistor. It will limit the current going to the LED, and it will also make sure that your LED do not get burned. But remember that its value minimum should be 100 ohm and maximum you can set any value, but remember, higher the value of the resistor, the dimmer the LED will go. An ideal value for this 5 volt 5 mm crystal type LED is 220 ohm. So I'm going to use a 220 ohm resistor. 330 is also fine. I'm going to use this 220 ohm resistor. So now to first of all connect the topmost LED. For that, connect the longer pin to the one end of the 220 ohm resistor like this. From the other end, connect it to any available digital input output pin. I'm going to connect it to pin number B3. So my programming will be such that the port B will be constantly toggling, but as soon as we press the button, it will initiate the break statement, which will make our loop to break, like we will come out of the forever loop. Now for the second LED, do the same, longer pin to the one end of the 220 ohm resistor. From the other end, connect it to any available digital input output pin like this. For the third LED, do the same. I'm going to use a pin of B1. For the fourth LED, I'm going to use a pin number B0 like this. Now for the button which will initiate the break statement, as soon as it is pressed, This is the push button we are going to use, easily available in the market. It's a tick type push button. It has two pins, name one as the signal, other one as the VCC. You can shuffle these two pins as well. It doesn't matter because it's a non-polar component. Now for this button, you basically do not connect it directly with you will need a resistor. This is a 10 kilo ohm resistor I am going to use. This resistor will decide either the button sends a 0 or a 1. As soon as the button is pressed, either it will send a 0 or a 1. It depends upon how we connect this 10 kilo ohm resistor with the button, either in pull up formation or pull down formation. Now I will connect this resistor in such a way that as soon as the button is pressed, a 1 will be sent. Now for that, first of all, the VCC pin connected to the VCC pin of the PIC like this. For the signal pin connected to the one end of the 10 kilo ohm resistor like this. From the other end of this 10 kilo ohm resistor send it to the ground like this. Now guys, from the same signal pin that was connected to the other end of this 10 kilo ohm resistor, you take out your output. For the output, you can use any available digital input output pin. I am going to use a pin number D1. Now take a look here. See, the one end of the 10 kilo ohm resistor is connected to ground. Whenever you see that the grounding resistor, this resistor, one end is connected to the ground, it means that once the button is pressed, a 1 will be sent. Always remember this. If this one end was connected to VCC, it means that if the button is pressed, a 0 will be sent. Now that's a sign. Now guys, this is our hardware, simple, very simple. So let me show you the hardware in reality. So this is the hardware in reality. That was the presentation. Now you can see that it's very simple. We have these LEDs here. You can see that we have LEDs. We have this push button. We are going to use this push button. And then we have PIC16F877A connected to a trainer board. That's all guys. This is simple hardware. Now let's go to the MikroC for PIC. So let me zoom in so you guys can see better because it's difficult to see. So let me turn on the magnifier. Now guys, this version of the MikroC for PIC I am using is 7.6.0. You can use a higher version also if available. I will also share the link to the video in which I have shown you how you can download and install this for free from my official website. Now guys, first of all, click on File, New Project. This window pops up, New Project Wizard. Click on Next, write the name of the project. I write here, what should be the name of this project? I write here break statement tutorial like this. Now guys, this is the path where the files will be created. This is the microcontroller you are going to use. We are using PIC16F877A. This is the crystal connected to pin number 13 and 14 pin of your PIC16F877A. I have a 20 MHz crystal over there, so I will select 20 here. Click on Next and Finish. Now guys, on the left side here, this window pops up. Press Ctrl S to save your work before you do anything else. Save it. Now guys, first of all, we initialize the LED pins. I write TRISB equals to 0 cross 0 0. I am making the complete port B go output because I am not connecting anything else on the 4 pins left on the port B. So my complete port B has been declared output using this command. Now initial state of the port B, I make it 0 cross 0 0 because initially I want no LED to blink or turn on by default. So this command makes sure that no LED turns on by default. So now we initialize the button. For the button we have TRISD.F1 equals to 1. Now see that for the input pins, TRIS register should be configured 1 for the respective pin. Here we declare the whole port output, so it was 0 cross 0 0. Every pin gets a 0. Now for the input pin, we are just dedicating port D, only pin number 1 as input, so only a single bit will be sent. If it was a complete port D, I was to send 0 cross FF. But now it's only a single pin, so it will be just a 1. And initially, as I had told you, that by default our button sends a 0. So once the button is pressed, a 1 will be sent. So by default it must be 0. Now we go to our forever loop. I write here while 1. Forever loop starts here, ends here. Now guys, what will happen if I try to use a break statement here? See, this is the break statement. I click on build. See, it's built. But break statement, if we use here, what it will do, our code will go out of the forever loop. It will come here. So this is not valid because it will go to the one time loop. So never use a break statement in the main forever loop. See, this is our one time loop and this is our forever loop. So never use a break statement inside main forever loop. We make another while one, like a forever loop inside forever loop. Now in this loop we will be using the break statement. So once the break statement is used, it will not hang the code. Else, if you use the main break statement in the main loop, it will go out of the main loop to the one time loop, and then your code will be hanged. So in that case, make another while statement inside the forever loop. Like once we use the break statement, it will move you out of this loop. So we will be still in our main loop to do other things. Now this break statement is here. What I do is that I make the port B blink. So this is by default off. I make it FF, and after some delay I give a delay of like 100, 200. I give a delay of like 200 millisecond, and then I will turn the port B off like this, and again there will be a delay of 200, like port B will be blinking with a delay of 200 milliseconds. And now this break statement, if executed, will move us out of this loop. So that's what we don't want. We only want the break statement to be executed once the button is pressed. So for that we take if port d dot f1 double equals to 1, like if the button is pressed. Okay, there we made a mistake. This is the command, just copy paste it. Okay, place it here, remove these. Okay, port d dot f1 write in this syntax format, else it will be an error. So if the button is pressed, then what should happen? It should break the code, like, okay, it will break the code. And if the button is pressed, break command will be executed, and we will move out of this forever loop to this loop. And for that we will have something like a pointer. So now if the code was here, then it will check, but if the code is here, then it have to wait. So for that what I do is that I add this here as well. I add it at another point like here. Now wherever you want the break statement to be checked, like button to be checked, if the break is pressed or not, you just copy paste this command over there. So I will check one time here, I will check one time here, and I will check one time here. So in between the blinking as well, if the break button is pressed, it will break out of the loop. Like code will already be too fast, but still it will be good. So we have the break statement. It will, all of these do one thing, that it will make us go out of this loop. Now to make sure that we are out of this loop, we do is that we will make the LEDs go high forever. So we take the port B, and port B by default once out of this loop will be high like this. So this will tell us that we are out of the loop. So it will remain high for, I say, 3 seconds. See, once we are in the main loop, this is an indication that we are in the main loop. By default, the code starts here forever loop, it will go into this forever loop, and it will keep on blinking the LEDs, and it will keep on checking if the button is pressed. It will check for the button is pressed 3 times in this loop, and if the button is pressed, it will break out of the loop, and then this will be the indication that we are out of the main loop. Now let's build this code. See, no errors. Now let's go to the hardware and burn it. So before that, turn on your PIC16 programmer tool to burn the new code. So this is our PIC16 programmer tool. I will also share the link to the video in which I had told you how you can download and install this software for free. Click on file, import hex file, but don't do that. Before that, select a microcontroller first. I am using PIC16F877A, this one. Now click on file, import hex file. This is the hex file we just created. Double click, click on write. Now now the code is being burned. We go to the hardware to see what is happening. So this is the hardware over here, and this is the code being burned. Let's see, let it burn the code. We will power up the circuit using the PIC3. So let's power up. Click on this on key to give power from the PIC. Okay, PIC has powered up the circuit. So see, it's perfect. Now see, the LEDs are blinking as intended. See, in the programming we have done is that after every 200 milliseconds the LED blinks. Now once this button is pressed, it should go out of the loop. It will break the loop. See, the loop has been broken. It stays on for 3 seconds. Then again it continues back in the same loop. So our break statement is working. Now see, I press the break statement. This is a button which initiates the break statement. See, once it's pressed, we are out of the loop. So that's what the break statements do. In very complex coding, it's a very useful statement. It will greatly help you to optimize your code. And this statement makes you to do the normal programming in such a way that you will not need the interrupt, because we don't have so many interrupt pins. On other pins, if you want to add a taste of interrupt, you will use a break statement. It will allow you to make a normal programming go look like an interrupt is working. See, I press the button again. See, now it goes out of the loop to the main loop. That's it, guys. If you guys have any questions, you can ask me in the comment section. Thank you very much for your time, guys. We'll see you in the next video.